All right. This is the video for Thursday, March the 26th. Hope that everyone's doing well and appreciate those who are faithfully watching the videos. I'm getting most of the homework assignments, but I'm also looking at who's viewing the videos, and let's just say not everybody is tuning in to get the instruction. That's going to cause some trouble down the road, so make sure that you make this video viewing part of every day. I'll probably make some ways of rewarding those who are faithful. Anyhow, let's do some review. Yesterday's homework assignment, you had a couple of connecting triangles, and you had to identify the perimeter and the area, perimeter and the total area of these two triangles. So let's remind ourselves, perimeter means the distance around the outside, and area is how much space is on the inside. Perimeter, you just need to identify the length of the three sides, add it up, and you've got the perimeter. And then our formula for the area of a triangle is 1/2 base times height. Well, let's go ahead and take care of perimeter first. Remember, the Pythagorean theorem says that if I have a right triangle, which is a triangle with one of these guys here, this one is a right triangle too, that the square, the sum of the square of the two shorter sides equals the square of the longest side. So a squared plus b squared equals c squared. So a couple of numbers that you ought to remember right away. A squared plus b squared equals c squared is, I want you to remember 3, 4, 5, and 6, 8, 10. Now this, what I've got drawn here on the board is not drawn to scale, but if you'll take 3 squared, that's 9, plus 4 squared, 16, that equals 25, which is the square of 5. 6, 8, 10 works the same way. 36 is our square, plus 64 equals 100, and the square root of 100 is 10. So if you are trying to identify a perfect right angle, this is a great way if you're working in construction, or you're building something, or you're doing a craft and you want to make sure that your right angle is exactly right, whether it's inches, whether it's feet, whether it's yards, whatever. If you can get one side to be 3 and the other 4 and this side 5, then you know that this is a perfect right triangle. It's got a perfect 90-degree angle. Just something to keep in mind there. So anyhow, today I want to talk to you about the area and perimeter of a rectangle. So if you have a rectangle, the length times the width is the area, and of course the sum of all four sides is the perimeter. Now we use some little marks, hashings, to show which sides are equal. If I put a mark here and I put a mark here, those single lines mean those two sides with a single line through them are equal. If I put doubles, that means those sides are equal. So if I know that this is, let's say, 2, and that this one is 6, then I know that because this line here says the same as this, that side is 2, this side over here is 2, this side is 6, this side over here is 6. So the perimeter, I would have 2 plus 6 is 8, plus another 2, which is 10, plus another 6. I'm losing track of what I'm saying here. Perimeter, 2 plus 6 would be 8. Plus another 2 would be 10, plus another 6 would be 16. I don't know, complete brain. I just completely forgot what class I was teaching there for a minute. Area is length times width, so we would take the width here, which is 2 times, so the perimeter is going to equal 2 plus 6 plus 2 plus 6 equals 16. The area is going to be 2. And let's put this in some. Let's say this is miles or meters. Let's do meters. This would be length times width, so 2 times 6 would be 12 meters squared. Remember, if you're talking about area, your answer is always going to be, the answer is always going to be squared. All right, a circle, so that'll be fun trying to draw a circle. The path around the outside is called the circumference. And the area on the inside, okay, the circumference, in order to find the circumference, you must know the radius. The radius is the distance from the center out here, okay? So this is the radius. And there's a constant relationship between the radius and the circumference. The relationship is circumference equals 2 times pi times the radius. And pi is our constant. That's our ratio, our relationship between the two. And pi, in this class, we will shorten to 3.14. It's a number that goes on infinitely, but 3.14 is enough for us, okay? So if I want to calculate the circumference or the length all the way around the circle, if I know my measurement from the center of the circle to the outside, that's my radius, and I'm going to double that, and I multiply it times pi, 3.14, okay? My area, though, has a similar relationship in that if I know my radius, I also can know my area. And my area is pi times r squared, okay? So I take pi, 3.14, and I multiply it times my radius squared. So let's say that, for example, my radius is 2. I have to do easy numbers, so I'm not spending a whole lot of time plugging things into calculators here. If my radius is 2, my area is pi, 3.14, times 2 squared, or 3.14 times 4. I plug that in, and I'm going to get a number just a little bit bigger than 12, right? All right, so that's how we calculate my area. So these are the two formulas for a circle, all right? The circumference and the area, you've got to know these. These have got to be placed in memory. In today's worksheet, there are addition, subtraction, multiplication, division problems, really focusing on sums, differences, products, and quotients when you have positive and negative numbers together. There's some fractions in there as well. This is a review. Of course, we worked on fractions yesterday, but remember that, and I'll spend just a second here. All right, let's say we have, I'm going to use really easy numbers here because the principle never changes. Let's say we have a negative 2 plus 4, okay? Which of the two is larger? The larger of the two is the positive, so I know my answer is going to be positive. And you have to think of this as movements on a number line, right? So I'm going to go negative 2, that means 2 to the left, 2 away from 0. I'm going to go 4 to the right, which is a positive, and I'm going to end up with a positive 2 as an answer, okay? So negative 2 plus positive 4 equals 2. I can write the same problem by taking these numbers and moving them around. I can say 4 minus 2 equals 2. It's the exact same problem. All right, what if I have, for example, what if I have a number that says 7 minus negative 5, okay? If I'm going to minus a negative, subtract a negative, that's the same thing as adding a positive. the two negative signs side by side. Two negatives make a positive. So 7 minus negative 5 is the same thing as 7 plus 5, and that answer is 12. All right. Let me do one example here. What if I were to say, I'm gonna pull one from the homework. That way, if you're paying attention to the video, you've got one for free. Negative 1/12 minus negative 3/4. Okay, negative 1/2 minus negative 3/4. Obviously, did I say 1/2? This should be 1/12. Sorry, negative 1/12 minus negative 3/4. The two negatives make a positive, so this is the same thing as negative 1 over 12 plus 3 over 4. Now, for me to add two fractions, they must have, if I'm adding or subtracting fractions, they must have the same denominator. So I'm going to change this to 12ths by multiplying it times 3. If I multiply this, the bottom times 3, I've got to multiply the top times 3. So I have a negative 1 over 12 plus 9 over 12. Okay? You see, I converted the fourths to 12ths. I just took my 4 and multiplied it by 12, and that way both my denominators are the same. And if I multiply the bottom times 3, I multiply the top times 3, because if I multiply them by 3 over 3, it's the same thing as multiplying by 1. In other words, I didn't really change the value. 3/4 and 9/12 is the same exact value. Now I have a negative 1/12. I'm going to use this number here, since my denominators are 12. I'm going to move my negative sign up here. That just helps us when we're adding and subtracting to make sure that the negative sign sticks with the numerator. Negative 1 plus positive 9 is the same as 9 minus 1. I'm putting positive 9 and I'm taking away a negative 1. That's going to give me a positive 8 over 12. Of course, I can simplify that since both the numerator and the denominator are divisible by 4. I can convert 8/12 to 2/3. There's my answer, all right, with all the work shown. Okay, the homework assignment is up. Look forward to hearing from you. Text it to me. Call me if you have any questions. Call, text, email, whatever you need to do. And we look forward to seeing you all tomorrow.